This episode originally aired in March of 2023.
Welcome to The Buzz. I'm Christopher Conover. This week, a look at Arizona's abandoned mine problem. It's tough to know just how big Arizona's abandoned mine problem is. A U.S. Mine Safety and Health Administration database shows there are about 1,300 abandoned mines in the state. But the Federal Bureau of Land Management estimates that number to be more than 200,000. While that number is in debate, the danger of an abandoned mine is not. There's the obvious risks, such as the possibility of a person or animal falling in a deep shaft. Then there's the environmental concern caused by waste from a mine. Joining me now is our show producer, Zach Ziegler, who recently returned from a reporting trip in a remote area of Yavapai County. Zach, welcome.
Hey, thanks for having me, Chris.
So let's start with where you were exactly and what brought you there.
Yeah, so I was in the southwest corner of the Verde Ranger District of the Prescott National Forest in an area known as the Black Hills. That's between Camp Verde and Prescott Valley. And in that area, the Forest Service is sealing up 6 mines that were originally spots where gold and silver were pulled out of the ground. Now, these mines have not been used since at least the 1940s, but they remain open and things can get in and out of them. The day I was there, which was just Wednesday, they were working on a mine known as the Uncle Sam mine.
So walk us through, for those of us who weren't there, what you saw at the site.
So when I say remote, I mean it. It was about 30 minutes on a dirt road. We crossed a stream in the area multiple times, something I hadn't gotten to do as an Arizona boy who grew up in the desert. 4-wheel drive was needed, and once we got there, though, our first stop was where they were building what's called a consolidation cell. Maria Magaha is the environmental engineer for the U.S. Forest Service's Southwest region. She told me what that is exactly.
This is where we excavated like a big hole here and put the contaminated waste in the hole, and then they covered it up with the excavated material. And it's about 36 inches of cover.
Now, Maria mentioned contaminated waste. What exactly is that?
So in this instance, it's the soil and rocks that were dug up from these mines. Now, this area was very commonly mined. There's gold, silver, and copper. We're about 10 miles south of Jerome, which was known for being a spectacularly wealthy mine. And still to this day, there is plenty of ore in those hills. We're also about 10 miles northeast of what was known as the Iron King mine, though. Today, that's a 500-acre EPA Superfund site because lead and arsenic has spread throughout the area, particularly because of the smelter that was there.
So what came first on this trip?
So when we got there, there was the morning safety meeting because it's an active construction site. That was given by Cameron Paez, who was with the contractor doing this work. That's Engineering Remediation Resources Group out of the San Francisco Bay Area.
Slips, trips, and falls. A lot of uneven ground. Mm-hmm. You guys all have boots on and are fairly used to working out in places like these.
So then we waited for a bulldozer to blaze the trail to the actual mine itself before we hopped into a Forest Service Jeep and headed up a very muddy, very rough road. When we got there, I asked Cameron what condition the road was in before they started working and if it's common that they have to build a road to seal a mine.
The road we took in, probably before that you could get a side-by-side through. Maybe a small Jeep or vehicle, but we got to get tracked equipment and haul trucks that are, 11, 12 feet track width. It takes us a fair amount of days. I mean, excavators, bulldozers, heavy equipment. A lot of these, there are existing roads, but we have to widen them and make sure they're safe to haul on.
So now you're at the Uncle Sam mine. What does that look like? Because especially for those of us in southern Arizona, when we think of mines, we think of the big open pit copper mines, obviously people don't necessarily fall into those.
The area right around the mine looked like they were getting ready to build something about the size of a house. They had scraped and leveled the land in the area, and it turns out that's where the prospectors had dumped the soil, and of course some arsenic and lead, that they were now removing. Here's a little more audio from environmental engineer Maria Magaha.
What these guys did is they removed the mine waste that was in here, and they hauled it down this road, the road we just came on, and buried it.
And she says they actually couldn't get all of the arsenic.
So we made a decision to go ahead and leave these hot spots here and cover them with 36 inches of cover material, rather than, keep excavating, deeper and deeper and just not get anywhere. We expect that there's probably a vein here that we're just never going to get to.
I'm sure when people hear that last bit of sound, they're going to clue in on something that I clued in on. A vein of arsenic?
Yeah, arsenic is a naturally occurring metalloid. So just like the minerals in the area, there can be veins of it that get scraped up. Earlier we talked about the Iron King mine and the Humboldt smelter. Lead and arsenic were the problem there as well, and that's about 10 miles away. Mining and smelting got into a vein there, and it ended up spreading it across the area. Now, today, residents of the town of Dewey-Humboldt blame health issues on this. That's something that I reported on in the past, and while no one lives here in this area near these 6 mines, that this area was called the Cherry Creek mines, there are obviously creeks. We crossed that one, which I mentioned earlier.
Sometimes if there's surface water, as you saw driving up here, we do collect samples of the surface water if it's available, and we look at if there's any contamination in the water, then we address those types of issues.
Yeah, because that's probably got to be a pretty big concern. I mean, I know that creek that we crossed, it empties into the Verde, which empties into the Salt, which is Phoenix's water supply, or a good chunk of it.
Exactly. And that's why we're doing these remediation sites, because we are essentially burying all that waste material that's on the surface. We're burying it, we're covering it with clean material, so that when there's stormwater and all that precipitation, that it's not migrating off-site into our waters. That's the objective here, to reduce or eliminate that contamination in the environment.
You've talked about the mine waste. What about the mine itself? Were you able to see it?
So up on a nearby hill from that ground that was scraped flat, you could see a fence and kind of see something else. And so is this the... No, that's a water tank. Right, yeah.
No, we're not there yet.
And then once we got to the top... Oh, here we go. Yeah, that's a big hole.
It's a huge hole. It's pretty deep. So what we decided to do here is we're going to build a metal cupola. It's a metal grate that we place essentially like a roof over the shaft to allow bats, to fly in and out. This particular shaft did not have any bats. However, we decided to go ahead and build this cupola for safety measures, and also because the shaft, we discovered, had water in it. Has so much water that the local rancher would like to use the water.
That's why I saw the water tank that I wasn't quite sure of what it was there. And there's also a solar-powered pump that will be lowered down at some point to pull that water up.
So she mentioned a cupola that will allow bats in and out. Again, because you were there and this is radio and our listeners weren't there, tell us a little bit what that looked like.
I asked that question, actually, of Mark Schwab. He's the Abandoned Mines program lead for this project.
With this closure, it will be 4-inch tubular steel that will go across the top with a gap of 5 3/4 inches, and and welded in place, and it'll be anchored on the outside. So It has to be at least 2.5 or 3 feet from the edge of the collar for safety, and it has to be anchored into the ground and then welded, properly. We'll have a hatch door so that they can get this pump down in there later to pump out the water and to service the pump.
We haven't talked about the part of the mine that most people probably are picturing in their head, the shaft of the mine. What's that look like now?
For folks who want to, they can go to the webpage for this episode. To describe it, though, the actual shaft was about 8 by 8 feet, and the water starts about 40 feet down, though it goes much deeper from there. At the top, though, the hole itself is much bigger. That's because the soil has slid into the cupola and making what's called an erosion cone. As we walked down the other side of the hill, too, we also saw another feature of the mine, what's known as an adit. Now, let me give you a quick terminology lesson here. A shaft is when you have a hole that goes in and out of a mine that is vertical. An adit is when you see that going in kind of horizontally, like a tunnel.
And this is it's called Adit 1, and right now it's it's kind of sloughed in, but that dirt will be scooped out of there, and we're going to close this with a 36-inch culvert with a bat grate on the end of it. So there was good bat habitat and bats in this adit. But at this level, it connects with the shaft, and the water level is the same. Before they leave with the earth-moving equipment, they'll use probably an excavator, just pull that out, and we'll be able to get a 36-inch culvert in there and extend it out beyond where the material is sloughing onto it, so it will remain open.
So from everything you're describing, this is not a quick one-day project. How long does it take to seal a mine?
So I asked that same question of Mark Schwab. He said sealing actually takes about a day per opening. It's a pretty quick process. Cutting the road is the bulk of the work on the Uncle Sam mine sealing.
So mining in this area dates back to the 19th century, maybe even earlier. How much is this just part of life in this area of Yavapai County?
So that was a question that I actually got to ask of the last person who was along on this trip. Her name is Frances Alvarado, and she's the geologist for the Prescott National Forest. Since she lives in the area, I asked her about how these issues around mining permeate life there, and she said it's definitely discussed, especially when there's something like a story or a public notice in the local paper, the Prescott Courier, or some other media outlet in the area.
You hear it pretty often. I'll hear it in the local papers. There's a lot of, like you said, the historical mines in the vicinity, because that's how these communities came about, because of the mining. I hear it a lot, especially working with the agency.
It's the part of your job that follows you home, and when you're opening up the Courier, it's like, oh man, yeah, here it is. Here's my work life coming into my personal life.
No, it's true. And if I'm driving around or hiking, I go, oh look, there's another site, and I kind of make note to self. I may have to address this one later.
All right, Zach. Well, thanks for taking us along on this trip.
Hey, anytime you want to send me out to some nice, beautiful corner of Arizona, I'm more than happy to go.
Great. You're listening to The Buzz. I'm Christopher Conover. We're looking at Arizona's abandoned mines and the hazards that they cause. As we mentioned at the start of the show, estimates of how many abandoned mines exist in the state really vary pretty widely. But two professors at the University of Arizona are hoping to change that by building a database that includes necessary information for a variety of governmental agencies, from the state mine inspector to the Federal Environmental Protection Agency. Mark Barton is the director of the Lowell Institute for Mineral Resources, and Julie Nielsen is the director of the Center for Environmentally Sustainable Mining. They spoke with Buzz producer Zach Ziegler.
How much of the state's abandoned mine problem do you think is a lack of knowledge about how big this problem is?
Well, that's a difficult question to answer, because we really don't know. One of the things that we're trying to do in this is to establish what the scope of the problem is. The reason for that is that what counts as a mine? In the old days, when the state was before statehood, Anybody who was out exploring for minerals would dig a hole in the ground. So at one end of the spectrum, anything that's a hole gets called a mine. And for that, there are over 100,000. We don't know how many there are. There are a huge number out there. And of course, they have a hazard associated with them because somebody could fall into them. They may have other issues. At the other end of the spectrum, we have the things that actually produced a fair amount of metal or sand and gravel or other types of things. And for that, it's a much smaller number. It's several, maybe 100 times fewer or more. It may only be in the few thousands of numbers. And for the really big one, it's really only in the few hundreds or few tens if we talk about the giant mines like the big copper mines today.
So mines weren't really registered until the 1980s, I believe. That sounds pretty late in the game to me. Is that the case? And is that part of the reason for all of this?
Well, there's been a lot of information that has been collected about mines, and when people would, say, file a mining claim under the 1872 mining law, that information would be recorded, and there were minimal restrictions on that. It wasn't really until the environmental movement came in that the regulation of what was done became an important part of mine operations.
I was going to just add that I think, harping back to the conversation we had earlier, that when you think of mine features, which is sort of a generic term for anything related, there's the actual pit where the ore was excavated, which can be a shaft. I took a picture of one in the Tucson Mountains when I was hiking on Saturday. Or it can be a huge open pit if it was a larger operation. But then you have all these waste piles. And I think we have to separate where the ore was excavated, which could be a site you could fall into, versus the contamination associated with the smelters, with the tailings, with the waste rock piles. And so I think it's important to talk about what these waste streams are. And as Mark said, the tailings from a lot of the operations between the late 1800s and 1960 were inefficiently extracted. So the copper, the gold, the silver was extracted, especially when you think back to gold from the Tombstone tailings when you were using horses to stamp on it to grind, the very crude extraction techniques. And then you often have a lot of residual metals left in that material that was not of interest. So whether it's arsenic or whether it's lead, which are two really common contaminants in legacy tailings, and you have this acid generating potential, which if that material is eroded off site, that material can decrease the pH of a stream, which if a pH becomes too acidic, that alone is toxic, just that low pH. It can kill fish. Fortunately, in Arizona, a lot of our highly acidic material stays in solid form on sites because we don't have such high rainfall, so that acid mine drainage can be, I'm going to say can because there's areas Mark will indicate, can be less of an issue than in Colorado and some other states where you have a lot more rainfall and this material's moving offsite into drainages.
Mm-hmm. So when it comes to trying to put together a comprehensive database of all of these abandoned mine sites in Arizona, people may ask, well, why do we need to know that? How important of a factor is it because of the possible environmental contamination that is there?
It's important for different stakeholders. So in particular, for the project that we're working on, it's funded by TRIF funding through the Board of Regents. And it was in response to a request from the ADEQ, the Department of Environmental Quality, to actually provide information that they could use to rank different areas for possible groundwater or surface water contamination. So that's one set of questions that we're trying to do. But we're also working with the state mine inspector. And the state mine inspector is very interested in the physical hazards. What are people going to fall into? In other cases, somebody may be interested in the dust hazard that's there. So the scope of what we're trying to accomplish with this project is really to meet in a realistic time frame, given the resources available, the needs of multiple stakeholders who actually have different questions, have different issues.
One of the other complicating factors is that in the late 1800s and the early 1900s, a lot of these tailings were hauled to the side of streams like the San Pedro River and the San Pedro and the Aravaipa stream, perennial streams, because they needed the water as a source to extract, to process the tailings. And so we have worked on the Tombstone tailings, which were actually hauled from Tombstone, where gold was extracted, over to the San Pedro River site at a place called Boston Mill, highly contaminated tailings. That's a BLM problem, Bureau of Land Management. The other site that I've worked on, which is a state Superfund site, is the Klondike tailings, which are along the Aravaipa Creek. That was a lead and zinc mine that operated in the 1930s and 40s. That's an ADEQ state Superfund site, and they have capped and contained that site. And then I could give two other examples of highly contaminated historic tailings, but they're on active mine properties. So the Magma copper mine in Superior had highly contaminated, highly acid generating material, but BHP and Rio Tinto are now excavating. They have a claim on that site. They're now developing that site for future ore development, and they absorb the cleanup costs of that site. And so they are actually doing that. And there's other examples of active mines that are cleaning up legacy sites. BHP has a whole legacy asset team. And so they are responsibly dealing with some of the historic sites that closed in the 1950s and 60s. So environmental impact, as opposed to falling into mine shafts. But some of these sites are managed by state agencies. Some of these sites are managed by active industry who have taken on the cleanup costs. And so I think that, as you were asking, we need to understand where all these sites are, which ones are being contained and taken care of, with Iron King being like the worst that we have in the state and the biggest mess that we have in the state. And EPA, because it's a federal Superfund site, has taken responsibility ultimately for that site. Although I would be interested to see how they're going to clean that up and contain that completely. The fact that these tailings were hauled historically to the banks of perennial streams makes them more of a hazard than they would have been if they were left on site like Iron King.
Something like this, where you're trying to track down all of these sites over such a large geographic area, how do you go about it? I'm guessing this isn't, searching the forest kind of thing. Just, everyone forms a chain and walks across Arizona in multiple directions. And what information are you hoping to get from it?
So there are many sources, as one can imagine, on this. So one way to do this is there are databases of different types that are handled by the U.S. Geological Survey, also by the old Bureau of Mines. So there are a lot of records on where things had been developed. Even just the simple maps, the topographic maps generated from early in the 20th century would show pits and so on it. So that kind of information has been digitized. And so we have a very large set. That's where the numbers of 100,000 plus, come from, is that each hole in the ground, when somebody made a map of that area, might have been recorded on it. Not all of them were, but many of them were. And so you can look at old maps, and there may be 100 or more on single map sheets that are in that. So that's a place that we can start with this. We're also using remote sensing to doing this, trying to use modern technology to help with it. And we're using other types of inference that come from our understanding of the basic geology, in areas. So when we try to rank these different areas in terms of their potential hazard, environmental or physical hazard, we try to use multiple different data sets, some of which are very specific. Where's that hole in the ground, like Julie took the picture of in the Tucson Mountains? Or where is there, square miles of rock that has acid generating potential, like down in the Red Mountain area by Patagonia.
Yeah, it sounds a little more complicated than just, getting two Excel spreadsheets and saying, okay, merge.
I wish.
When it does come to those issues, I mean, what is the information that these stakeholders, they're telling you they really need?
Well, everybody, I would say at a basic level, would like a GIS or geographic information system type of approach, so that they could pull up on their phone or their tablet or whatever they were using and be able to locate things and know something about the basic content of what's there. Is it a hole? Does it have acid generating potential, and so on? What would be the toxic components, the metals and so on that would be in it? So I think that's information that's shared by virtually everybody. When you delve into it a little bit deeper about regulatory agencies or groups who are trying to mitigate it, they all want something a bit different. Some people want to be able to add information to it as they go out and check sites. Other people want to do sort of a regional assessment. Okay, if I'm going to consider developing this area, what are some of the things that have to be brought into consideration? So it depends on who the ultimate user is. But it starts with that sort of geographic information. What's there, and what are some of the important characteristics?
Well, thank you both for spending some time with us today and talking about this.
You're welcome. Our pleasure.
Our pleasure.
That was University of Arizona professors Mark Barton and Julie Nielsen. And that's the Buzz for this week. Tune in next week as we look at where Arizona's snowpack goes when it melts and what communities benefit from that water. You can find all our episodes online at azpm.org and subscribe to our show wherever you get your podcasts. Just search for The Buzz Arizona. We're also on the NPR One app. Zach Ziegler is our producer with production help from Samantha Larned. Jim Blackwood is our production engineer, and our music is by Enter the Haggis. I'm Christopher Conover. Thanks for listening.
Arizona Public Media's original programming is made possible in part by the Community Service Grant from the Corporation for Public Broadcasting.